Stand yourself free. Like so, don't fall over. You'll suddenly realise how bad it's raining. Right, to be you. Very much. Keep it to a tight 3, okay? I won't interrupt anymore. Well, Scott mentioned I'm an engineer. I started to learn about the Firth of Forth Bridge this past summer, taking an online course in structural engineering. It was very interesting to me. I found out that there's somebody who's probably much more of an expert, a young lady who's sitting behind our group of Oklahoma. But what I wanted to tell you is just what I've learned about it. The bridge is pretty amazing. It was built basically to get across the Firth. Right, a few years before the Forth Bridge was built, the Firth of Tay Bridge was built. It's not that easy, is it, dude? Yeah. Try saying 4 fascinating facts about the Firth of Forth. Many more fascinating facts about the Firth of Forth. So, keep going. You're doing it, brother. The Firth of Tay collapsed shortly after it was built. It was something that's called a simply supported beam span bridge. They didn't account for the strong winds that it would withstand. The engineer that was building the Firth of Forth had already thought that he wanted to build this cantilever truss bridge. And you'll see that it looks different than any kind of bridge that you probably have seen before. Well, the cantilever truss was new, and it had to actually be engineered, it had to be designed. They had to use calculus. Okay, calculus had been invented about no dates, right, Scott? No dates. We don't do dates. You know the rules. In the middle 1600s, Sir Isaac Newton invented calculus during the Great Plague of London. So it still took almost 200 years before they put it to use to build a bridge. When they were building the the railway company knew that they had already had a black eye because 80 people died during the collapse of the Firth of Tay Bridge. So not only did the engineer building the Firth of Forth Bridge have to do it right, make it not fall down in heavy winds, he had to make it overcome the stigma that the public had that bridges are unsafe. So it looked very, very, very strong, in addition to being very, very, very strong. And in engineering, we try to always say that form follows function. In other words, that you're going to make something do what it's supposed to do first and then look good. Well, in the case of the Firth of Forth, it had to look good to do what it was supposed to do. So the people had to have the faith and trust that it was going to work and not collapse, or it wouldn't have been built. They when they built the bridge, it was the first bridge that ever used steel, carbon steel. All the bridges before that were made out of iron. Iron is much more brittle. Steel, new material, it had to be analyzed, and all the structural elements had to be considered, as they were building it. So that was new. It also, in bridge builders' terms, span is everything. They try to see how far they can make a bridge go between the columns. And the farther it goes, the better. Well, the Firth of Forth was the longest spanning bridge in between the columns when it was built. And it survived, that record survived for many, many, many years. There was an American engineer who saw it after it was built, and he said the bridge was just a monstrosity, that it was an overbuilt bridge. There was too much metal, too much steel used. It could have been much more eloquent, a lot less steel, a lot less cost. And he criticized it at the very beginning of when the bridge. 30 years later, this American engineer got an opportunity to build his own bridge in Canada. Well, he was pretty old at that time, and he didn't get a chance to go out to the job site too often. And he started getting reports back from the foreman that the pieces weren't fitting together. And he knew that he had designed it right, at least he thought he did. And in fact, the bridge company in Canada said, well, we want to analyze your design. We want to have your design looked at by a third party, somebody else look over your shoulder. He said, absolutely not. If it's not my bridge, I don't want to build it. So he took full responsibility for the bridge. And during the construction, these pieces weren't fitting together, and he didn't go up to look at it. Finally, he got the word from his foreman that they just can't put it together the way it's being built. what had happened was this engineer tried to beat the 1,750-foot span that the Firth of Forth bridge between those columns at 750 feet. He made his bridge 1,850 feet, but he didn't account for the extra weight of that steel. So as they were building it, it was collapsing in front of their face. It was actually falling as they were building it. And sadly, it collapsed during construction and killed 80 construction workers. So what he forgot was that form follows function. And when he criticized the Firth of Forth, the form was part of the function. The form was what showed the public that it was going to stand. It's still there today, and it still carries, correct me if I'm wrong, Scott.
No, I've got a question.
200 trains a day. So think about that. A bridge built in the early 1800s, first one made of steel, first one that used actual design principles and calculus, still standing today, still serving 200 trains. Yes, sir.
That's all very well and good. Can you name at least one movie that the bridge has been in?
No,
Rubbish then.
Very
good. You know. Ladies and gentlemen, John from Oxford, thank you very much.